Yes. So, Tarun, we are just waiting for the participants. Just one more minute, we will start.
No issues, no issues.
Yeah. I think, Cheryl, we can start.
Yes, ma'am.
Yeah.
Hi, good evening, everyone. On behalf of IIT Madras FedEx Smart Center and POMS India chapter, I would like to welcome all of you. It is a pleasure to welcome such a distinguished group of participants. So welcoming the faculty members, students, research scholars. I believe we have students from IITs from all over India here today, IIMs, SP Jain, Manipal, SRM. So thank you so much for taking the time to join us for this seminar series on strategic choices in digital operating models, cloud procurement, and 3D printing as a service by our distinguished professor, Tarun Jain. Before we begin the session formally, I would like to add some context to the vision, focus, and ethos of the IIT Madras FedEx Smart Center with a short video. So I request you all to please turn your attention to the screen while I share this video. Established in 2023, at the heart of the IIT Madras-led FedEx Smart Center is the drive to nurture and transform the next generation of leaders through knowledge dissemination programs led by distinguished faculty and talent outreach initiatives. Here, students, researchers, and faculty work closely with industry experts from FedEx to solve real world logistics and operations challenges. These young minds work on live projects that include everything from last mile delivery optimization to predictive maintenance and dynamic routing. Let's take a look at how these students thrive within the ecosystem of the IIT Madras-led FedEx Smart Center.
I think my work at the FedEx Smart Center contributes to real-world logistics scenario by providing a solution which is applicable to last-mile delivery and mid-mile delivery, and it is something which is very much relatable to real world.
So I come from a non-technical background and I learned Python and everything from scratch. FedEx has empowered me to do well in terms of problem solving and the coding.
For every student that walks through these doors, the IIT Madras-led FedEx Smart Center is more than just a place for knowledge advancement. It is a place for community bonding, friendship, peer learning, and strong social connections. And for many students, it is home. Thank you so much for watching. I would like to hand over the floor to Professor Ashinda Kaur to introduce our speaker. Over to you, ma'am.
Thank you. Thank you, Cheryl, a lot. So on behalf of POMS India chapter, on behalf of the board, I welcome one and all who have joined this seminar. Thank you very much for joining on a weekend, and I'm sure it would be really interesting talk. And we initiated this seminar series 2 years back under the POMS India chapter banner. This is more to empower, to encourage our research scholars in India, right, so that they can learn from world-renowned researchers. And today we have an opportunity, to have. First, I would like to say thanks to Professor Tarun Jain for accepting our invitation. And I'm very happy to introduce Professor Tarun Jain, who is a professor and IMB Chair of Excellence in Production and Operations Management area at IIM Bangalore. He has done fellow program in the same institute, and his research interests include operational issues in online business models, and he has published his work in production operations management, naval research, logistics, decision sciences, EJOR, and the Journal of Operational Research Society. He has also been awarded many awards starting from 2014 onwards. I could see that, so almost every year thereon, there is a prize. He has the recent one he has got is Basant Kumar Birla Distinguished Research Scholar Award in 2021. I am Udaipur Professor of the Year Award for 2019. Airbus Group Scholar IIM Bangalore 2014 POMS Emerging Economist Doctoral Student Award. Production Operation Management Society in 2014, Canara Bank Award, and Emerald Best Research Paper Awards at Society of Operations Management and Calcutta in 2015. I'm sure Professor Tarun, students and research scholars would really be benefited today, after listening to your lecture, which the title of today's session is Strategic Choices in Digital Operating Models, Cloud Procurement, and 3D Printing as a Service. So today's session, Professor Tarun would have two research problems to discuss. So after first problem, we will give a pause for 5 minutes to have question answers, and then second problem. But after the second problem, we can have Q&A for both the problems as well. So I would request everyone to mute your screens. So at the end for Q&A, you are welcome to unmute and ask the questions. So let's listen to the session. Over to you, Professor Tarun.
Thank you, Professor Ashinder, for having me and organizing this seminar. I'll just share my screen first. So just give me 30 seconds. And
Is my screen visible?
Yes, yes.
Okay. Well, thank you for having me. So, what I'm going to do today is I'm going to break this talk into two problems. The first idea is along a digital technology, which is 3D printing, and I'm going to first focus on the pricing of 3D printing as a service. And the second idea is along the pricing and the capacity allocation in the cloud computing industry over there. So let me first start with the study number one, which is on 3D printing as service, economic analysis of pricing and co-creation. It's a joint work with Prof. Jishnu Hazra, who is my colleague in IIM Bangalore, and other co-author is Prof. Ram Gopal, who is at the Warwick School of Business, the University of Warwick. So, what is 3D printing? 3D printing is nothing but making the final objects in a layer by layer fashion. It's an old technology, but recently the growth of the technology has been having is being having at a very faster rate, and much of this is because the printing speed has improved, the quality, the resolution is increased, and the feed material cost structures have gone down. And as a result of which, what we are seeing is a lot of this applications towards producing complex designs in aerospace, automotive, healthcare, and CPG industry. How is this 3D printing value chain different from the traditional manufacturing? So if you look at the traditional manufacturing, what firm would do is upfront decide the product quality, offer the product to the customer, and the customer is going to consume the product. Now, what is happening in this 3D printing value chain? The upstream is the 3D printing device providers like companies like HP and Carbon. What they do is they upfront invest in preparing the 3D printing design files or templates along with certain functionalities in the printer. The printer is offered to the customers. Now, the customers, what they're going to do is they're going to utilize this printer and the templates, further invest to customize the final design, incurs the quality cost, and finally, using those design files, the customers are going to print the product, right? That's how the value chain has changed. And now recently what is happening is the companies like HP and Carbon, rather than directly selling, the 3D printers, they're offering this 3D printing as a service model. And what they're choosing is a couple of pricing models. One is a fixed fee pricing model, and other is a pay per bill pricing model. What is fixed fee pricing model? Fixed fee pricing model is a model in which, in a certain contract period, I upfront pay a certain amount of money. This contract can be, let's say, of 3 years. I upfront pay the fixed amount of money, and then during the time you can print as many builds or as many items during the time over there, but the pricing is fixed. The other pricing model which is used by companies for a certain kind of printers is paper build pricing model, where the charges are based on the actual number of builds or prints, right? So if you look at the left hand side, this is from the website of Carbon. For a certain printer, they're charging $50,000 per year, and irrespective of number of builds, you have to pay $50,000 a year. And if you look at right hand side, this is from the website of HP. For a certain printer, they offer it on a paper build pricing model over there. The question we are trying to address is which of the pricing model is appropriate for which particular kind of printer, or for what particular kind of functionalities. So, if you look at, this comparison between the fixed fee and the pay per bill pricing model, right? It's not a new problem. There's a lot of literature in operations management, information system, who has been looking into this problem. So, but how are we unique? We are unique in a sense that we are bringing, some features which are specific to 3D printing industry, which is one is the, complexity of the jobs, and other is the extent of customization between the customer and the 3D printing device provider. So, and we are seeing the impact of these unique aspects on the selection of the pricing model. So let me start. So what is complexity? So the complexity is nothing but the sophistication of the 3D printing design. For example, GE for a certain nozzle for engines, they prepared a complex design which will convert these 20 parts into a single component, is single durable component. And as a result of which, if this part is successfully printed, it's going to give a very high value to the customers, which is G in this case. But the problem is, if the part is very complex, then it's possible the design may fail. So there's a trade-off here that if I'm able to print a very complex design, and if the design is successfully printed, then I get a very high value because of utilizing that final printed build. But on the other hand, with high chances, since I am making a very complex design, the design may fail during the design phase itself. And something similar happens in automotive industries where many of these businesses print, the integrate or the complex designs, but they tend to face high failure rates because they're printing this complex designs over there. So we kind of captured this trade-off in our, exposition, which I'm going to show you in some time. And the other unique aspect is the co-creation, and that's something I initially mentioned. And in this particular value chain, we have two key players. One is the 3D printing device provider, and other is the customer. Now, each of them has a certain role in this co-creation. What's the role of the provider? The role of the provider is to give the design files, to provide certain functionalities, which will convert the 2D, 2D pictures to the 3D models. Give certain functionalities to the printer. So this is the value which is given by the companies like HP Cup, which are nothing but 3DS providers. And the other value in this co-creation is coming from the customers who basically utilizes these templates and softwares and exert certain efforts and prepare the final design. So other unique aspect in this value chain is this co-creation between the 3DS provider as well as the customer, which you also capture in our analysis. So again, motivated from this, we study a model setup where on the upstream we have the 3D printing device firm like HP Carbon, and the downstream we have the customers who are going to use the printer to print the object. The upstream firm, the 3D printing device manufacturer, invest in quality to prepare the initial customization features in the printer as well as the initial design files, offers the printer to the customer on a service model with this preloaded design files. The customer is going to now exert the effort and further customize the object. And it's again going to incur the cost of the customization, which I'm going to call it as cost of quality customization. And the final product consumption value is modeled as alpha times QC plus 1 minus alpha times QF, where QC is nothing but the quality effort by the customers, and QF is nothing but the quality efforts by the firm, right? So the overall quality is alpha times QC plus 1 minus alpha times QF whole multiplied by beta. So what is alpha? Alpha is nothing but the extent of customization, which basically the customer is bringing to the final design, right? And if you look at beta, what is beta? Beta is nothing but the complexity of the job. If the job is very complex and the job has successfully printed, then it's going to give a high value to the customer. So it means as the beta is going to increase, the value to the customer is going to increase. But on other hand, right, if the beta is high, the job is very complex, then with high chances it may fail during the product design phase. So we model the probability of failure as nothing but lambda times beta. It means if the beta is going to increase, the probability of failure is going to increase. And therefore the probability of successful print is nothing but 1 minus lambda beta. Now, in case a job fails, in that case, there's a liability cost which customer is going to face, and we denote it as L, right? In case of any of these job failures, the unit liability cost for each of the failure, we are going to model it like small L over here. In our model, during the contract period, each of the customers are heterogeneous, and they have a certain usage requirement, which we are going to call it as use frequency. In general, we denote the use frequency by mu, but the use frequency varies from customer to customer, and it's a private information for customer. And way we model mu is nothing but, which is nothing but the use frequency is nothing but uniformly distributed between 0 to mu h over here. So it means the customer is interested in getting finally mu objects, but when we design an object, it's with lambda b probability it's going to be fail. There will be failure of the design, and therefore the probability of success is nothing but 1 minus lambda beta. And as a result of which, the total number of jobs which a customer has to print to get the mu jobs is nothing but mu divided by probability of success, which is nothing but mu divided by 1 minus lambda beta over here. Where again, I repeat, lambda beta is nothing but the probability of failure. And as I mentioned earlier, a key question is to study the pricing contracts. So first, we are going to study the fixed fee pricing contract. And in the fixed fee pricing contract, customer pays a fixed fee F to get the printer during the contract period. And the next pricing model is the pay per build pricing model, where for each of the build, you pay a unit price U. So let's say if I print, let's say 10 objects, I'm going to pay 10 U. If I print 100 objects, I'm going to pay 120 U worth it. So two pricing model, one is a fixed fee and other is the pay per build pricing model. And the timing of the model is as follows: is first firm decides the prices under both the pricing model, what's a fixed fee or what's a pay per build price in each of the pricing model. Then the customer decides whether the customer want to opt for a 3D printing as a service offering. If yes, then it has to exert effort to further customize the design and finally print the object over there. So the two events, first is setting the prices and second is basically the consumption by the customer. And these are the key questions we are going to answer today. So first is, what's the impact of the co-creation of customization? How does the relative ability of supply chain players to customize the final product influence the unit prices under both pay per build and fixed fee pricing model? And second is, how does the complexity of the product designed by the printer is going to impact the pricing strategy, which is the first is on the impact of the parameter alpha. The second is nothing but the impact of the parameter beta. And finally, we're going to answer a question, which is the best pricing model for a 3DS firm? Should I go for a fixed fee pricing model? Should I go for a pay-per-build pricing model? So overall, in this research, we contribute to three streams of research. One is the pricing issues. Second is the co-creation or collaboration issues in supply chain. And third is the recent stream on the issues of 3D printing supply chains. So overall, we are unique. We look into the two pricing models, model the nuances of co-creation between the upstream, the downstream firm in the value chain. And finally, we bring the nuances of product complexity and failure, which is specific to 3D printing supply chains. We solve this problem analytically. Much of the technical part is in the paper. The paper is already published, but I'll just quickly tell you the structure and then I'll get into the key insights of the problem. So what we model is first is the customer utility. Customer utility is nothing but for each of the successful design, I get a value out of it. So there's a value gained from the printed object. Net of the price paid, right? This is the price paid for the 3D printing services under both fixed fee and the pay per build pricing model. Finally, I incur a design cost, which is for both failed as well as the successful designs. And finally, in case a design fails, I incur a liability cost structure. The next is the payoff of the 3ds provider, which is nothing but the payment received from the customer for using the printer, and minus the initial customization or the cost incurred to prepare the initial design files. right? So next, what I'm going to do is I'm going to get into the key takeaways, the key insights of the problem. So first, let's study what's the impact of the relative ability of supply chain players on the unit prices over there. What is the impact of the parameter alpha on the pricing strategy? So we found that the pricing impact of the parameter alpha on the pricing strategy is kind of same under both the pricing model, which is fixed fee and the paper bid. Specifically, what we find is that at a very high value of alpha or a very low value of alpha, it makes sense to charge very high prices. Way we characterize this is like one threshold policy. If alpha is very high, if the complex, if the extent of co-creation by the customer is very high, as further alpha is going to increase, the unit prices are going to increase. On other hand, if alpha is low, then as the alpha is going to increase, the prices are going to further increase. In fact, this is nothing but a simple U-shaped relationship between the price and the alpha. Which means that if alpha is very high, it means if the customer has a very high impact on the overall design, then what's going to happen is, since customer is going to control most of this design, the customer is going to invest a lot into preparing the higher quality product. And since customer is going to invest a lot, it makes sense for the firm to basically charge high to extract a higher value from the customer. On the other hand, if alpha is very low, in that case, let's say alpha tends to 0. In that case, what's going to happen is it's the upstream firm or the 3D printing firm is going to almost control the entire, design. And in that case, what's going to happen is, the firm is going to invest a lot into preparing the almost ready templates. Since they invest a lot, what's going to happen is they're going to charge very high prices. So the insight is same for both fixed fee and the paper bid pricing model. Next, we ask a question: should you always charge high price for the printers which are used for very complex designs? Again, we find it's not always true. In fact, we find a threshold policy. In a fixed fee pricing model, the threshold policy is dependent on the expected usage, which is nothing but the parameter mu. So we find that if the expected usage is very high, then as the complexity of job is going to increase, then it makes sense to increase the fixed fee. On the other hand, if the expected usage is low, if the complexity is going to increase, then we are saying that no, don't increase the price, rather decrease the prices. The reason is what's going to happen in the fixed fee pricing model. What happens is typically the fixed fee pricing model tend to screen high use customers. And if the use frequency of these customers are going to be very high and the jobs are complex, it means they're going to make many prints, and these are basically complex prints. So with high chances there will be many successful prints. So they're going to get high value. So it makes sense to charge high price to them. On the other extreme, what's going to happen? If let's say the usage is low, and if I charge very high prices for the complex job, what's going to happen is the high use customers will not be encouraged to adopt it, and as a result of which, for complex jobs, you want to reduce the prices. We had a slightly different threshold policy in a paper build model, which is dependent on two things. One is the probability of failure parameter lambda, and other is the expected usage, which is nothing but mu. We find that only if the product failure probability is low, which is lambda is low, and the expected usage, which is nothing but the mu, is high, then only what's going to happen is you should increase the price with a higher complexity. Otherwise, in all other cases, it makes sense to decrease the prices. The difference between the two structure is, in a paper build model, since the customers pay for each of the unit, you tend to charge your service for both low usage as well as the high usage customers. Whereas in the fixed fee pricing model, you only tend to attract the high usage customers. Now, what's going to happen is, let's see, if the usage is high, but if the probability of failure is also high, then what's going to happen? The low usage customers will not prefer the service, and as a result of which, you will tend to reduce the price in that scenario over there. And therefore, there's a slight structural difference in the impact of complexity in fixed fee and the pay per bill pricing model. Finally, what is a best pricing model from the perspective of 3DS providers? In terms of the extent of customization, we find a two threshold policy. We find if alpha, which is nothing but the impact of customers on the overall design, is very, very high above threshold, or if alpha is very, very low below the threshold, in that case, the firm should offer a pay per bill pricing model. In between, the firm should only offer a fixed fee pricing model. Again, the intuition is if alpha is very high or alpha is very, very low, what's going to happen is the overall quality of the product offering is product printed is going to be very high because any one of them is going to control the design. And in that case, what's going to happen is you're going to charge high pay per bill price because we're charging a high pay bill price to larger spectrum of customers is more profitable because here you screen both the low usage as well as the high usage customers. In between, what you do is you strategically charge a high fixed fee price to only screen out the high usage customers who only offer the fixed fee pricing model, right? And in terms of the complexity in the product failure rate, if you see the x-axis of this diagram is the complexity of job, which is beta, and y-axis is the product failure rate parameter, nothing but lambda. So if the lambda is high, beta is high, the probability of failure is high. So which is basically this white region, where I'm pointing the cursor. So here we see that the fixed fee pricing generates higher value for the customer because what's going to happen is the chances of product failures are very, very high. So only way is to make more money is to charge slightly high fixed fee and offer it to the high users customers to through a fixed fee pricing model. On the other extreme, if the complexity of job is very low, irrespective of product failure rate, we find that again offer it through fixed fee pricing model. In between, we go for a pay per bill pricing model over there. Yeah. So yeah, these were the key insights for the study number one. Yeah, we can take some questions. Anyone, any questions at this point of time? In clarification on the model, motivation, anything I should repeat?
Yeah, very interesting, Professor Tarun. So we can open if somebody has any question, you can unmute and
Based on chat also, I can monitor the chat also.
yeah. Or you can type your question in chat window.
We can move to the next one then.
Yeah, I think we can move. Maybe at the end we can have the question, but you can please keep typing your question in the chat window. Yeah, we can move to the next. Yeah.
So let's move to the next study, which is on the. Let me change my screen. My screen is visible, right? Right, perfect. So the next study is on pricing and capacity strategy in cloud procurement, the economic analysis of multi-cloud decisions. Again, this is joint work with the same team with Prof. Jishnu and Prof. Ram Gopal. So what is cloud computing? Whether a business is in retail sector or a real estate sector, whether a business is in education or sports, much of these businesses are nowadays relied on web-based applications. The previously, companies were hosting these applications on on-premise service. What now they are doing is they are using this public cloud infrastructure provided by companies like Amazon, Google, and Microsoft. And through internet, they're hosting their applications on these public servers. And as a result, overall, rather than investing on on-premise service, what they're doing is they're moving much of their, the infrastructure requirements on a public cloud computing spaces. Now, these are not only use cases for, the private organization, but if you look at the federal agencies in, US, India, Australia, and Canada, they're also investing a lot in, sourcing the public cloud infrastructure. In fact, if you see, in US federal agencies are expected to spend around $8.3 billion by the end of this year on cloud computing infrastructure services. In Indian government, around $1.4 billion was spent in 2024. And this is expected to increase at at a growth rate of around 13.1%, and it's expected to reach around 4.24 billion by 2023. Now, these agencies, basically these are the federal agencies. These federal agencies not only choose a single cloud provider for the contract. In fact, they go for a multi-cloud strategy. For example, a national informatics center in India historically has gone for multi-cloud with Azure and Google. In US, for this, Department of Defense, Joint Warfighter Cloud Capability Program, they have given a multi-sourcing contract to Amazon, Microsoft, Google, and Oracle. Something similar, UK government, Auckland, New Zealand government, as well as the Australian government are implementing. So how they implement this multi-cloud infrastructure? Basically, there are various utilities. For example, the utility which I'm showing you here is the IBM Multi-Cloud Manager, or which you can, host multiple public cloud spaces, and dynamically you can switch your loads from one provider to other provider over there. So execution is quite simple because of availability of all these cloud managers. What's the benefit? The benefit is this reduces the vendor lock-in, improve the resilience, help you to manage the extreme events, which outages, risks. Also, what happens is since much of these instances are sourced through auction competition, the procurement cost also goes down. So here we ask a question here is, how do you design this multi-cloud infrastructure? How many vendors I should, or how many clouds I should choose to design my multi-cloud infrastructure? That's something we're going to address in this problem. Next, what's good? If you look at these government agencies, they not only purely rely on the public cloud infrastructure, but they also invest on on-premise servers, or which we're going to call it as private cloud. So how the execution happens? So let's say I'm a government agency, I have servers over which I'm hosting my application, and the server is facing the application load, the demand load. And in case if the demand exceeds the server capacity, the excess I'm going to source from the public cloud infrastructure providers like IBM, Google, Oracle, and so on. Right. So this strategy, which I'm using, both public as a private and the private infrastructure, private cloud, is known as hybrid cloud computing. And again, some new question arises. If I go for a hybrid, what should we go for? What should be the investment in the private cloud infrastructure? Or on one extreme, should I only go for public cloud? Should I only go for a private cloud? Should I go for a combination of a public or a private cloud? Should I go for a hybrid strategy? And other challenge in this industry is, if you look at in a multi-cloud architecture, I'm writing contracts with companies like AWS, Azure, Google Cloud, Oracle, IBM. All of these businesses tend to differ with each other, which lead to the differences in the cost structure. So, what are the sources of this cost differences or heterogeneity? The scale of capacity is different, different energy costs, different regulations, regulatory environments, tax structures are different, hardware costing is different, and as a result of which, what's going to happen? The cost is going to vary from the cloud provider to cloud provider. That's one thing. So cost is heterogeneous. And second is the cost is the private information for each of the players. So whatsoever the cost structure of AWS is, that AWS only knows. What's the cost structure of Azure? The Azure only knows. But one thing we know is it's a private information and it's going to vary from player to player. So question is, how does this heterogeneity in the cost structure impact the size of the vendor base? How does it impacts the private cloud capacity investments? That's also we're going to address in this problem. Next, another issue in this cloud computing industry is there are a variety of service models. One of the model is on-demand instances. The second is reserve, and third is the hybrid of both on-demand and reserve. What's the difference between each of them? In an on-demand instances, after you see the demand, you book the capacity. So for example, let's say, this is a cloud and I have an app and app is connected over the cloud. Now let's say I have instantaneously demand of 11 instances dynamically through my platform. I am going to only source 11 instances. Suppose my demand was 6 instances. Dynamically on demand, I am going to source 6 instances. So this is nothing but the on demand capacity service model. The next service model is reserve capacity instances. In the reserve capacity instances, a business need to upfront reserve certain number of cloud capacity instances. Let's take an example. In this example, I have an app over a cloud, and what I've done is I have, upfront source, let's say 4 instances. Now, let's say my demand is for just 2 instances. In that case, I will be using only two will not be used. If let's say the demand was 6 instances, in that case, what's going to happen is, I'm going to lose the demand corresponding to 2 instances. I'm only able to fulfill the demand for 4 instances because my capacity is capped by 4 instances. So this is nothing but the pure reserve instances. And third is nothing but the hybrid of both on-demand and reserve instances. In the hybrid model, first upfront you book certain reserve instances at a certain pricing scheme. The later what's going to happen is, if let's say demand happens and the demand is more than the number of reserve instances, dynamically you can buy on demand instances on a different pricing scheme. So this is nothing but a combination of on demand and the reserve instances. So therefore the question for the federal clients is, which instances should I go for? Should I only go for source only on demand instances? As a business, should I only rely for reserve instances, or should I go for a hybrid of both on demand and reserve instance pricing model? Right. That's also we are going to address in this problem. So overall, this research is on intersection of 3 streams. One is IT investments, because there's a private cloud capacity investments we're going to study. Second is because since it's a sourcing model, so the second stream is IT outsourcing. And third is operational issues in the cloud computing. So our work is on the intersection of all these 3 streams. How very different from the previous research in the operational issues in cloud computing? First of all, we're the first one to study the multi-cloud architecture. Second, we consider the hybrid of public and private cloud in the presence of cost heterogeneity. Third, since this is the federal procurement, we kind of model the pricing through reverse auction mechanisms. And finally, we consider a more general setup with n providers and one federal client. And we also consider all 3 possible provisioning mechanisms, which is on-demand, reserve, and the combination of both on-demand and reserve instances mechanism. So again, motivated from this idea, we study a stylized model setup with one firm and n public cloud providers. So each of the providers have capacity C. The capacity is finite. It's basically C. But later in the robustness check, we also consider the heterogeneity in the capacity over there. But in the main model, we consider as a fixed capacity for each of the provider. We say the capacity C. The client demand load, or the federal client's demand load, is random, which follows a distribution, let's say G. The federal firm invests in the private cloud capacity, which is mu. And since it invests in the capacity, it incurs the cost of capacity investment, which is nothing but K is a function of mu. If the mu is going to increase, what's going to happen is the cost of capacity investment is going to increase. So K is an increasing function of mu. The client firm, this federal client firm conducts a reverse auction among this n public cloud providers and select m lowest quote vendors which are declared as winners for sourcing the cloud instances. As I said, there's a heterogeneity among these cloud providers. Their cost structures are going to vary from each of the provider, and the cost structures are the private information of the cloud providers. So only thing what the client knows is that the cost is going to be uniformly vary between a bound, which is nothing but VL and VH over there. That's a common information of client, but exactly the client doesn't know what's the cost of each of these providers. And what happens in practice is these companies like Amazon, Google, when they offer capacity to prime services like on demand, reserve, or hybrid, whatsoever leftover capacity they have, they offer it in an alternate business model. They call it spot instances. For example, Amazon has reserve on demand, but the whatsoever remaining they have, they offer it as spot instances, which is like an alternate market for them. So we also consider that. We said all these vendors, if they have any leftover capacity, they can offer in the spot market, which is spot instance market. And we say the demand for the spot market is DI, and it follows a distribution F. And the expected revenue in the spot market, we are going to denote it by S naught over here. Right? So this was the key model setup. The timeline is as follows. The client first invests in the private cloud capacity. It decides the extent of capacity investments mu. In case it goes for the reserve instances, it also need to decide how many instances to reserve upfront. And client also decides how many providers to select for a multi-cloud configuration, which we're going to denote by M. Next, what happens? So client has made this multi-cloud and the capacity decision. Next, the bidding happens. So cloud provider determines based on the requirement profile of the client, determines the how much they are going to quote towards the client's requirements. And finally, what's going to happen is the client is going to collect the bids and is going to compare the bids and it's going to select the M lowest quote vendors. Then next, the demand for the client is going to happen. And in case the demand is higher as compared to private cloud capacity investment, also the reserve instances, then the balance it's going to source through on-demand instances. If let's say that the client has chosen to choose upfront announced to source any on-demand instances from the M selected vendors. Finally, in case any capacity is left at these cloud vendors, they offer remaining capacity towards the spot instances. So this was the key timeline that we considered in the problem. Again, we solve the problem analytically. All the characterization is in the manuscript. The manuscript is already published. And let me tell you the structures of the payoff. The client's payoff is nothing but the revenue it makes by fulfilling the load minus the payment it pays to makes to the winning vendors for the cloud services. Since the client also invests in the private cloud, so there is a private cloud capacity investment cost. And since it runs the private cloud, so there is an operational cost of running the private cloud, right? If you look at the vendor's payoff is nothing but since the vendor is selling, the winning vendor is sending, instances to the client. So there's a revenue which is going to flow from client to the vendor. So expected revenue from the client. Plus, in case this particular vendor has some leftover capacity, it can offer to spot market. So there's expected revenue which is going to flow from the spot market. And finally, there's operational cost of running this service. So the last is the operational cost structure. What is the decision of client? Client is going to decide how many vendors or how many clouds to choose. Second is, in case I invest in private cloud capacity, what's the extent of capacity investments? And finally, if I choose to go for reserve instances, then how many? What's a quantum of what's how many instances I need to upfront book? And the vendor, since vendors, given the client requirements, the vendor has to decide how much to bid. Right? So this is basically the structure and the decision making of each of the player. Again, next I'll get into the key takeaways or key insights of the problem. So first question we've addressed is we understand how does a vendor bid in this federal procurement? Because if you understand the vendor behavior well, then we can understand the cloud capacity, the client's capacity allocation problem very well. So we find that the vendor's price quote or the vendor's bidding behavior is slightly complex It depends on a lot of factors. It depends on the cost structure. It depends on the payoff from the alternate market or the spot market. It depends on the capacity. It depends on the client's private cloud capacity investments. And it also depends on how many vendors which will be selected out of this auction competition. I'll just share some key interesting insights. One of the insights we find was if the capacity of the vendor is large as compared to the demand, then the bids of the vendor is low. The intuition is look, if given a demand is fixed, if the capacity is large, then the expected utilization of each of the vendor is low. Means the probability they're busy is going to be low. It means it makes sense for them to lower the price quote. By similar intuition, if you look at this third one, if the client invests a lot in the private cloud capacity, then again the vendors are more aggressive, they bid low. The intuition is if the client is going to invest a lot in the private cloud capacity, then the expected requirement for each of the vendor is low. If given the capacity of the expected requirement of each of this vendor or demand load is low, the utilization of the vendors are low. If the utilization is low, the bids are also low over there. So overall, we find if the utilization of the vendors are high, if they're more busy, they're going to quote high. If the utilization is low, then what's going to happen? The bids will be low over here, right? So that's what was the structure which is coming from the vendors. Next, we answer a question. We saw three instances: on demand, reserve, and hybrid. On demand, you book upfront. Reserve, on demand, you see the demand and source. Reserve, you book upfront. And hybrid, you choose the combination of on demand and reserve. The question is, which instances should federal client prefer? Should a federal client go for only on demand? Should it go for only reserve? Or should it go for a combination of both on demand and reserve instances? Well, we find that it always makes sense for a federal client firm to go for a on-demand instances reverse model. Right? I repeat, it always makes sense. We find that it's always optimal to source on-demand instances. It's never optimal to reserve any instances upfront. The intuition is since the federal clients are not often reserving any instances upfront, it means they're signaling that the utilization is low because they're not upfront, booking certain capacity. What's going to happen is since the vendors see that the expected utilization is low, they're going to quote low prices. At the same time, what's going to happen is there's a bidding which is happening, which is again going to drive down the price of on-demand instances. And therefore, it makes the on-demand instances preferable for federal client to source. And secondly, remember, in on-demand instances, mismatch cost is zero because the reason is client sees the demand and source the on-demand instances. Late in the paper, we also look into a scenario where it's possible that there's a possibility of outages, which is a very low probability. Typically, it doesn't happen. But in case the outages are prominent, in that case, what may happen is we show that it may make sense to often reserve certain capacity, which is slightly intuitive. Next, we ask a question: how do we decide the size of vendor base? What's extent of private cloud? And how does the heterogeneity of cost structure impacts the size of the cloud, which is nothing but the vendor base size, as well as the private cloud capacity investments. So we find that if the heterogeneity of the vendor's cost structure is going to increase, then what's going to happen is the client is going to choose only few vendors, right? On other hand, if the cost differences or the heterogeneity is low, in that case, the client is going to give a contract to more number of vendors. It's going to have a multi-cloud with large number of cloud providers, right? But we find that the public cloud investments are non-monotonic in the cost heterogeneity. In fact, we find if the heterogeneity is very high, then the cloud provider should invest low in the private cloud capacity. The client should invest low in the private cloud capacity. In case the heterogeneity is very low, again, we show that it makes sense to invest low in the private cloud capacity. In between, we show that it makes sense to invest high. So in fact, it's nothing but an inverted U-shaped relationship. The intuition is, look, if the heterogeneity is very high, then what's going to happen is, look, some of these players have very low cost, some of them has very high cost. So selectively through auction, I'm going to screen the low cost vendors. These have low cost, and as a result of which, what I'm going to do is I'm going to source a lot from these low cost vendors, and I'm not going to invest a lot in private cloud capacity. On the other extreme, if the heterogeneity is low, then what's going to happen is all of this, in extreme case, all of these providers have something similar cost structures. And as a result of which, if the heterogeneity is low, we saw that you need to choose more number of vendors. Since I'm choosing more number of vendors, what's going to happen is I'm going to allocate my load across many vendors. So if the expected load source from each of the vendor is low, and therefore the utilization of each of this vendor is low because they get a because of the many vendors they get a lower load, and as a result of which, what's going to happen is if they expect a low utilization, they're going to quote low. Since they're going to quote low, we found that, look, you source more through public cloud, and rely more on the vendors over there. In between, we find that you need to invest high in the private cloud infrastructure. And finally, the last question we address is, what is best for the federal client? Should I only go for a public cloud? Should I go for a private cloud? Should I go for a hybrid cloud capacity? We find it depends. It depends on various supply related factors. One is the vendor's capacity. If the capacity available is very high, or the number of vendors in the market is very, very high, overall capacity in the market is very, very high, in that case, go for a public cloud providers. If the available capacity is low, number of vendors is low, go for a private cloud. Somewhere in between, go for a hybrid cloud infrastructure. In case the cost heterogeneity is very high or very low, we show it goes for it makes sense to go for a pure public cloud. In between, we find conditions under which you go for a private and the hybrid cloud. But one thing we found is, in long run, if the industry is going to mature, it means if the number of cloud providers are going to increase, the available capacity of each of the vendors is going to increase. And since industry is going to mature, the heterogeneity is going to decrease. What will happen in long run? We'll see more and more public cloud computing happening in the federal, the federal sourcing. Yeah, so these were the key insights of the main paper. Apart from that, in this work, we had many robustness check. In main paper, we had same capacity of all the vendors. Later, we said, okay, what happens if the capacity is heterogeneous among the vendors? We said in the main model, we also had the spot market demand to be homogeneous, similar distribution. Later, we consider heterogeneity. We also look into the capacity dependent cost structure, utilization dependent alternate market. We also considered the data security concerns. The main model was a risk neutral player. We also consider risk aversion. We also look into the multi-cloud infrastructure, integration cost structures, and in all of these extensions, we find our key takeaways, which I showed you earlier, all robust. Additionally, we had some extra insights specific to each of these robustness checks. Yeah, so this was the key takeaways. Any questions? Happy to address each of them. Yeah, thank you, guys.
Thank you. Thank you, Professor Tarun. We'll be having a question. So there is a question in the chat.
Okay.
Smriti wants to know if vendors are much more and they participate in multiple bidding competitions. So Smriti, want to ask the question?
Good evening, sir.
Yeah, good. Go ahead, please.
Sir, if the vendors are much more large in size and they participate in multiple bidding competition, then what can happen?
One idea we have, if the vendors are more and and they're large, we show that it makes sense to go for a public cloud infrastructure. Right? That insight is coming. If N is high and the capacity is high, then you'll see, because the supply market is large, so it means that the bids will go down, go for a public cloud infrastructure. That insight model is coming. But what I'm modeling here is a single bidding competition. I'm not modeling a repetitive bidding competition because the auction problems, because the model setup is very complex. And in this complex setup, it's very difficult to characterize the equilibrium under the repetitive setup. But yes, that's an interesting question. But I'm not addressing the issue of the multiple bidding competition altogether over there.
S-
So what
s-
I'm doing is I am having so typically what happens is if you look at in India, government will have certain requirements. They will say this kind of instances, and the auction happens, and people are going to court, and the award is contracted. The contract period is over, and that's the timeline I'm looking at. Yes, go ahead,
So, sir,
please.
we can say that if there will be a multiple bidding competition, then the security breaches can be happen.
Why it will happen?
Sir, I'm asking. Maybe it can happen or
No, no. So first of all, look, the security issues are very low, especially in the federal cloud, federal sourcing, because these are not regular servers. These are slightly specialized servers. They have to follow a lot of this federal, standards. So if you go to this AWS Google website, Google Cloud Compute website, just search the public cloud standards. So they have a lot of compliances to follow, which ensures that there are not much breaches, there are not much outages. So the regulation kind of controls that. But what we model as a part of security is that look, if I have some sensitive data which I don't want to dump up on the public cloud, then which is like a constraint in this problem, then what will happen? That's part of that extension. What?
Yeah.
okay, sir. Okay, thank you.
Sure. So we have another question from Mr. Anup Kumar. Yeah, it's in the chat window also you can read. Do you think all the talk additive manufacturing is a hype?
Can
It's
uh,
the question. Do you think all the talk additive manufacturing is a hype? Yeah. Do you want to
what
unmute and talk, Anup? Yeah.
Yeah, we've been seeing this technology for around 20, 30 years. But then in India, I haven't seen that taking off compared to subtractive machining, right?
you're right.
And
So yeah, go ahead.
and cost-wise, like if you plan, see, I was planning to invest in additive manufacturing in Kerala because Kerala is more of a nature-friendly country, sorry, state. And but it doesn't make real sense unless the product is in demand. The final product is in demand, and like you can compete with the cost of subtractive machine product. There's no point invest.
You're right. So, look, Anup, we are not solving the problem whether this technology is feasible. We are assuming that for certain use cases the technology will be offered, and then we are asking question for a given complexity and given way the templates are designed or level of customization is for this specific printer. What's the best pricing model for? From the perspective of HP and carbon. So you're solving the problem from the perspective of businesses like HP and carbon. You're right. It's old technology as I earlier mentioned. It hasn't taken off. The growth is slow, but what has happened now recently, the precision has improved. The feed material cost structure has slightly gone down. So overall, the adoption is higher, but much of the adoption is in the sophisticated use cases over there. It's more engineering, or sometimes you see Nike printing shoes, and these are like shoes which are highly sophisticated for athletes. So in those use cases, which are slightly expensive use cases, they are being adopted.
Because getting a pure roughness of like 0.06 RA in shock absorbers you can get only through for grinding and all that.
Right. Yeah,
And
you're
maybe
right.
like we have CBAM coming up in April, like exports to Europe. Now you'll have your carbon, measurement and all that. Maybe I don't know, additive manufacture might go up. You think?
Maybe again we have to see where it's going to move, but you're right. As you said, look, one relies on hybrid machining. It means that, look, if something is high volume repetitive, then I want to go for a normal manufacturing. Something is low volume, maybe like spares or something like that. In that with prototyping, I can use the additive 3D printers for that.
And for defense, I think it's roughly you can weld it actually, like in subtractive machine, you can weld it. But what do you do with the additive manufactured part, in defense, critical parts, right? So a lot of,
Yeah.
lots of question marks actually at this technology. That's it.
No, you're right. You're right. So you're thinking from the user's point of view. My perspective was from the seller's point of view over there when I was solving that problem.
If
I was
someone wants to invest in machine, he'll actually think of these angles, right? Is the product sellable? Is the cost,
yeah.
justified? Basically, if I invest in such machines, it's justified. So.
Yeah. Right. No, Mr. Anup, recently there's a lot of demand coming up. Like, when we have more startups and, this thing, I have seen even in the medical devices area, so like people who are trying to develop new technologies, new products, like, so startups are struggling and, they are in need of like some 3D printing providers, design solutions. So probably if you will go to different, people are working on startups, coming up with new products, there is a high demand, like, 3D printing. Yeah.
Yeah, lightweighting and like critical parts maybe that can't be produced by
Exactly.
attractive machine. Those are the areas I think in concentrate.
Yeah. Correct. Mr. Anup, do we have any other question from the participants?
No, thanks.
Hello.
Any other question from any other participant? Yes.
Yes.
Who is this?
I'm Omkar. Am I audible?
Yeah, yeah, Omkar.
Yes, you are. Please
Yes,
go ahead.
I have two questions in specific. The first question, how do this organization manage the data governance while procuring the cloud solutions for digital manufacturing? Like, how is it actually done? The whole governance actually plays a bigger role here.
Sorry. Okay. The two things you're saying. How do you? One is cloud, and then second you said digital manufacturing, right? So
Yeah.
can you repeat your question? Can you again elaborate slightly? Yeah? What do you?
So, like, in the organizations, while procuring the cloud solutions, right?
Correct.
There are
Mm-hmm.
certain data governance we need to take care of, especially
Correct.
in the case of digital manufacturing. How do
Mm.
the organization take care of it?
Look, I see your point. You're saying that if the organization has, so first of all, look, you need to you need to classify the data, right? So if your data is highly, sophisticated, confidential, if it's a user-based data, then through regulation, maybe in some cases you can't put it on a public cloud, and as a result of which, organizations put that in a private cloud over there, right? But some functionalities, when there are not much concerns, you can utilize the public cloud infrastructure over there, right? So that's what in one of the robustness check we show that if the security concerns are going to increase, then the extent of private cloud is going to increase, and the expected public cloud procurement is going to fall down over there. And of course, in federal, there are other issues. For example, where should the location of servers? So many federal agencies says that, look, it has to be in same country, similar locality, within that proximity. You have to follow a certain, disaster-related protocol. So the regulation kind of ensures that the compliance at the data center level happens.
Okay. Also, sir, I did have one more question. If
Good. Please.
like the memory problem, like this whole thing is, and like opting the cloud is always like a trade-off between capex and opex. The constraint and the conditions, like the matrix that you shown, do they take care of time frame as well, or is it only for short term? Because if you're going for a longer term, having a inbuilt memory could be a better thing, like, on source, on spot memory. Yeah.
Yeah. So, look, what I showed you is a one period model,
Hmm.
but not in this study, in another study, which is on the public private cloud, as a one of the robustness check, we also look into the discounted problem that you invest in capex funds and then, cloud you're sourcing multiple times over there. There we show that the structure of this public private is same. Only thing is because the direction of trade-off doesn't change because of the discounting model, and much of the insights are robust. Something similar will happen in this one also. Intuitively, your insights will not change. Only thing is the magnitude-wise threshold and other results might change it there.
Okay. Thank you so much, sir. It was nice.
Yeah, is there any other question? Please feel free to type, your question in the chat window. Yeah. So one more question has come from Mr. Akash Kale. His question is about the modeling aspects of pricing problem. Can the problem be modeled as a bid price optimization problem or auction strategy similar to revenue management problems?
So I think, Akash, you're asking a question. How did you want to talk, Akash?
Akash, can you unmute and
Uh, Hello, good evening, sir. Am I audible?
Hey, you're perfectly audible. Go ahead, go ahead.
So I noticed a lot of similarities in the way the pricing decision problem that was discussed during the session and traditional revenue management problems that we uh, study usually in literature for airlines and railways. So,
Yeah.
like, can similar modeling aspects be used for this particular problem, or there are other challenges that are involved?
So, as you rightly said, I have borrowed those learnings from auction theory and revenue management to characterize the bid pricing. What's going to happen is because way I model it like a reverse auction, which is equivalent to set price auction mechanism. In that case, it's a truth revealing happens, and people reveal the price code. So that's what I will use some of those frameworks that you mentioned in my analysis over there. So much of the discussion is in the main paper over there. So if you put the title, you will be able to see the full paper, and I've done the math in that part over there. But you're right, I'm borrowing those principles from auction strategy in the economics literature. Yeah. Anu?
Oh, thank you, sir.
Akash, sorry.
Thank you, Akash. Yeah. So any other question? Okay. In the meantime, if some question come, Professor Tarun, I have this question. Generally when we talk about services, which is very different from dealing with the goods. So where it is very difficult to first, capture the demand specifically, the second problem. I really don't know what would be the demands going to be like, once like, we start using it. So what challenges you have faced in, characterizing the parameter while capturing the demand, all this thing?
See, the way I model demand is nothing but distribution. So if you see, if let me
Hmm.
go to the model diagram, you see the client faces a demand which follows a distribution G. In my numerical
Okay.
study, I assumed it uniform, but in a robustness, I think I assume one normal also. But my key trade-off
Okay.
direction was not changing. My insights were not changing at all. In fact,
Hmm.
I had closed forms for general demand distribution. They were not neat closed forms, but later in the paper I reported in a uniform. But I had appendix. I gave the general one later. But I didn't make
Hmm.
any much assumption on the demand form. Demand is just like a parameter structure because you see, much of my insights are not a function of the demand side factors. Much of this is based on vendors' capacity, number of vendors, cost heterogeneity over there.
Yeah. So here we can demand is, say, more in the capacity terms.
Sorry. Can you repeat, please?
I think there is an
Uh,
echo.
uh, uh,
Yeah.
Can you please repeat, Achanda?
Yeah. Right. Am I audible now?
You're audible.
Yeah. No, that's what I'm saying. Like, I cannot actually, like, mostly in this kind of services, I cannot estimate a priori what could be the capacity required. Like, let's say from that angle. So how to, unlike like, our goods dealing, when we are dealing with the physical goods, it's very easy, to define. So how you have faced this challenge, while
So in
addressing
fact,
the,
this was in fact one of the unique aspect of this problem. We said, look, if you look at auctions, if you look at physical good, you know how much quantity you're bidding for. In this case, what happens is
correct.
you give the requirement profile, which is like a distribution. Right? This demand follows distribution, you use the private cloud capacity, so you kind of know the expected
Correct.
requirements. You don't know the actual requirement. So what vendors are doing is, what they're
Correct.
doing is they're characterizing using the expected to a function and coming up with a billing strategy over there, right? But what if you look at way client is going to report, if you see, the federal agencies, what they do is in the auction document, they mention that look, this instance is this day, this will be the load expected through history because they have been always using maybe for some use cases that look how much is the load. So they kind of know the load patterns. They kind of share it as part of the auction document, which is like the requirement profile for the client over there. Audible?
Right. That's interesting. Very interesting, Tarun. Yeah. Any other question we have? Right.
Hi, Professor. Professor Rashid, Professor Tarun, this is Samrat.
Yes.
Yes.
I have one question. I think I mean, you're specifically addressing the issue of pricing, but from the perspective of vendor cost heterogeneity, how do like service providers actually keep track of market dynamics in terms of the pricing and stay competitive?
Sorry, so you are talking about the problem number two, right? Heterogeneity. Can you repeat? So these are the vendors like Google and cloud. So what's the exact question, Samrat?
Yeah, the question is like how do these providers they keep track of let's say the market dynamics and keep their pricing competitive?
So for them, look, if you look at what impacts the cost structure of these businesses, it is function of many things. It's function of scale because the reason is these are like large servers. So if the servers are larger, then what's going to happen is you can use the economies of scales because you have a common cooling system, same area. So what's going to happen is the scale is high, the unit cost is high. So they tend to invest in the larger structures over there. It's function of the energy cost. They also write algorithms to optimize, the energy usage and other things over there. It's complex. It's also how they're using the infrastructure efficiency. So it depends on all these factors and which impacts the cost structure for these businesses over there.
Yeah, thanks. I think what you explained is more from the perspective of the providers. But if you look at the requirement of the client, and then
Client,
to
okay,
be
okay.
competitive
You're
in that
right.
environment.
So client has, you're right. If I run a private cloud, I tend to incur a operational cost structure, which is basically, which is function of, again, it's function of the energy cost structure, the hardware cost structure, right? So in fact, what happens is some of this, I forgot the name, some of this public cloud infrastructure providers, maybe AWS has a calculators on the website where what you can do is if you can tell them the architecture, the hardware, the load, they kind of estimate what's approximate the cost of in-house cloud and what's the cost of outsourcing cloud over there. So there are mechanisms inbuilt utilities one can use to estimate that part. Yeah, so now
Thank you, sir.
So do we have any other question? Right. If not, then I really want to extend thanks to Professor Tarun. I'm sure, both the are very interesting and it would be very helpful to the research scholars, especially like, when we are now living in this era of all web world and, web any service as a web as a service, the cloud as a service. So this is a really key point, not only limited to, 3D printing or, this thing. Most of the services are going to be like, like that, especially in the procurement field. I do see that, the export import thing, like, when a lot of documentation is required, companies are like looking for like, some services which can like, streamline, their whole smooth flow of information across borders, like, so there I do see lot many such applications would be useful, like, which service provider to choose, like, and what kind of capacity. And I'm sure, like, this will have a many applications down the line, and it is really useful for the research scholars from the problem framing point of view, methodology point of view, and how to, like, present the insights and the results, like, and that too to the application. So this is, I'm sure this will be very useful for the research scholars here. Thank you very much, Professor Tarun. I would see that, we have in the list, we have another board member, Ruchita. Hi, Ruchita. Can you hear? You want to say few words, Ruchita? Professor Ruchita Gupta is there. I think I'm not able to reach out to her. Okay, that's okay. So, Cheryl, would you like to conclude the session?
Yes, ma'am. On behalf of IT Madras FedEx Smart Center and POMS India chapter, I would like to extend our sincere gratitude to all the participants for being here for today's session. A very special thank you note to Professor Tarun Jain. Your insights, expertise, and engaging discussions made this session very informative and also inspiring. Thank you so much for taking the time for curating the session and sharing your knowledge with us. Also, thank you to all the participants for being here today. Yes.
Thank you. Thank you. Professor Tarun, we will share this video with you, and if you would permit, then, we will share this video with the POMS US body to be sent to YouTube channel of POMS. So, but before that, we will share this thing with you and take your permission and all consent. Yeah.
The screen once and let you.
Yeah. Right. Thank you.
Thank you.
Thank you.
Thank you
Thank you
for
very
having me.
Thank
Thank you
you.
for organizing this. Thank you.
Yeah. Right.
Thank you,
Thank you.
Professor.
Thank you so much. I'll leave. Thank